Hi everyone, and welcome back to this channel. In the previous video, we looked at how you can implement a stack using a linked list. In today's video, we are going to be looking at how you can write the code that implements a stack using the linked list data structure. Just in case this data structure is not familiar to you, I'm going to leave a comment in this video description where I explained the linked list data structure in detail. And I've also written some unit tests so that you can make sure that the data structure meets the expectation. That being said, let's continue. Welcome back. The implementation source code and tests can be found at the following GitHub link over here, as you can see. Please don't forget to star the repository so that people can find it out easily. And also, I must emphasize that uh, you should make sure you've watched the last two videos where I explained the stack data structure itself before proceeding into this video. Okay. Okay, so I'm going to be explaining the code now. Uh, this code have been written in Golang. Okay, so the programming language I'm using here is Golang, but I will make sure I explain in detail so that you can implement it in any other language that you use. Okay, so this is the test that I've written so that we can ensure that the data structure meets the desired expectations. The first thing that we have here is the stack struct. Okay, so a struct is similar to a class, okay, in Java or in JavaScript. And when you have a class, it has properties, right? So the same way a struct has properties, and those are called fields. Okay, so the list field here is of type singly linked list, right? So it is a type of a singly linked list. As I've explained earlier, that we're going to be implementing the stack using a singly linked list. The first method here is the size method, and this does not take in any parameter, but it returns the size of the stack. Okay, so since we are using a linked list here, right, we're going to return the size of the linked list, which also equals the size of the stack. Okay, so that is what this method does, like nothing much, right? And second function here is just to check if the stack is empty or not. So it is called the isEmpty method. It returns a boolean, true or false. Okay, so we're going to check the size of the stack. So if the size is equal to 0, then it is empty, right? So we return true. Otherwise, we return false. So that's the function of this method over here. The next method here is the push method. Okay, so this allows us to add a new element to the front of the stack, right? So it takes in the element parameter, which is an integer in this case. Of course, this can be anything, but I've decided to use an integer here, and it returns a boolean. Okay, so since we are using a linked list and we want to add to the top, right, we want to add to the front of the list, so we're going to be adding to the head of the list over here. So if you watch the previous video, I mean, this should be very simple to understand, right? So we're going to add the element to the front of the linked list, which is at the head. Okay, so then we return true, meaning that the push was successful. Okay, so that is the function of this method over here. All right, so now we are at the pop method. So the pop method is the inverse of the push method. Okay, so if the push method is adding to the head, then the pop will be removing from the head, right? So that's what the pop method does, and it does this in a constant time. over here, as you can see. It's just a constant time, a single operation, right? Okay, so this method returns uh two types, which is a boolean and an error. Okay, and you will know why we are returning these two you will know why we're returning these two types at the end of this explanation. Okay, so first we're going to check if the stack is empty, right? So if you're trying to remove from an empty stack, that means that that operation is invalid, right? So return false and return an error that the stack is empty. Okay, so otherwise, if the stack is not empty, then we're going to remove the head of the list, of the singly linked list. Okay, then we return true and nil. So this means that there is no error. So return nil, and this true means that the pop operation was successful. So that is the function of this method over here. The pick operation allows you to check the element that is stored at the top of the stack without removing the element. Okay, just like you want to check out which elements are at the top of the stack. I mean, that's what the pick operation does. And this happens in a constant time, right? So it's just a single operation. uh it does not take in any parameter, but it returns two types, which is an integer and an error. Okay, so first we're going to check if the stack is empty. Okay, so if the stack is empty and you want to try to pick the stack, then it returns 0 and an error saying that the stack is empty. Okay, so you can't pick from an empty stack. That's invalid. You can't check what is at the top of an empty stack, right? I mean, that is invalid. Okay, otherwise we're going to return the element at the top of the stack. So we're going to get the element at the top of the stack, which in this case is the element at the head of the singly linked list, and we return nil. Okay, meaning that there is no error. Just in case you're wondering where we get the get method from, this is an abstraction from the singly linked list implementation. Okay, so if you check out where I implemented the singly linked list, you will find out how this get operation is implemented. Okay, but since it's done once, we don't have to rewrite it, so it's an abstraction, like, right? All right, so that is it about the pick up. You can also search a stack. Okay, so you can search a stack. That takes a linear time because you have to check for each element in the stack. So that takes in the element that you want to search for, and it returns a boolean and an error. Okay, so these are the two types that is returned. So the first thing to do is to check if the stack is empty. Okay, so if the stack is empty, then we're going to return false and an error saying that the stack is empty. You can't search an empty stack, right? That is not valid. Otherwise, we're going to return, okay, we're going to check the link, the singly linked list. If it contains the element that was passed. Okay, so this contains method 2 has been implemented in the singly linked list data structure. So it's kind of like an abstraction, as I explained earlier. Okay, so, and by the way, in case you're wondering what this is going to return, this is going to return true if the singly linked list contains this element, and false if it does not. Okay, then we're going to return nil. So nil means that there was no error. Okay, so that's the meaning of this nil here. All right, then the final method here is the print stack method. Okay, so this is just a way to print the stack. Okay, nothing much actually. It's just a way to print the stack, and we're going to be using the print list method that has been implemented in the singly linked list data structure already. Okay, so that is what you don't need to pay more attention to this, right? Okay, I just had to explain why it is here. Okay. Okay, so that is how you write the code that implements a stack using a singly linked list. So over here I've written the test that checks that each of this method meets the expectation. So we have the search method here, right? And I have the test written. I have the push method, as you can see. I've tested the pop method too, and the pick method. Okay, so each of this method has been tested to ensure that the data structure meets the desired expectation. All right, everyone. That is the end of today's video. Thanks for staying till the end of the video. Please don't forget to subscribe. It is very important, so that you can be notified when a new video is uploaded. And also, just in case you have a question or a suggestion, please put it in the comment box. Okay, and if you enjoyed the video, please hit the like button. It really gives me lots of motivation to continue producing videos like this. Okay, so thank you very much. See you in the next video.